So clearly sample size is important to researchers because it affects the precision and the certainty with which we can infer population parameters from sample estimates. So to talk more about sample size, I'm going to review some basic statistics. So first, distributions. Distributions are collections of measures. We could talk about the shape of those distributions and the spread of those distributions. And we can also characterize distributions with measures of central tendency. So common measures of central tendency are mean, median, and mode. So this is a shortcut way to describe a sample in which values are very different. We can talk about the mean of the sample, or the mode of the sample, or the median of the sample. And you should be sure that you have a good sense of the differences among those definitions. The other important characteristic of distributions is dispersion. There are a number of measures or ways to express dispersion. One is the range, the lowest value to the highest value. So to give some sense of how spread out that distribution is. Another is deciles and quartiles, the expressions of where 25% of the values fall, where 50% of the values fall, and so on. The most common one for statistical use is variance. So variance is an attempt to describe deviations from the mean. So distributions that have larger average deviations from the mean are more spread out. And if every value were the same, then there would be no deviations from the mean, and then of course there would be zero variance. So these deviations from the mean are characterized as the score minus the average, so xi minus x bar. But because some of those deviations are positive and some of them are negative, and in fact for the important distributions we're dealing with, which are symmetrical, all of the positive deviations equal all of the negative deviations. We can't talk about average deviations, so we talk about average squared deviations. So that's what variance are, and of course standard deviation is the square root of the variance. And again, you should be sure that you're comfortable with the definition of those terms. Some more basic statistics to go over this quickly. A normal distribution is a standard bell-shaped curve. It's important that you recognize that the distribution is symmetrical about the mean, meaning that there are as many values above the mean as there are below the mean, and more importantly, the dispersion is identical above the mean and below the mean. So as you go out a certain point to the right, you're capturing as many scores as if you went out that same distance on the left. And the mean is the high point of this distribution, which means that the mean is equal to the median is equal to the mode. A standardized normal score is derived from a deviation of standardized scores. So that means that you're taking the observed score and subtracting mu, the population mean, and dividing that by the population standard deviation. A standardized normal distribution has a mean of 0 and a standard deviation of 1.0. That standard deviation is, we use the letter S to refer to standard deviation and the Greek sigma to refer to the population value. And z-scores are the distance away from the mean of a standard normal distribution. And z-scores, of course, will be used in statistical tests. A sampling distribution is the distribution of values that results from taking all of the samples of a given size and plotting their means. So if we had a population of 100 and we wanted to take samples of 20, we would draw a sample of 20, calculate the mean, and plot that point. And then we would draw a different sample of 20, calculate the mean, and plot that point. And when we had all possible different samples of 20 drawn, and we plotted all of those means, we would have the sampling distribution of that population for samples of size 20. For reasons we won't get into, we know that the mean of a sampling distribution is an unbiased estimate of the mean of the population. And we also define the standard deviation of that distribution as the standard error of the mean for the population. So this S sub x bar is the standard error of the mean, and that is equal to the standard deviation of the sample divided by n, the size of the sample. The standard error of the mean is a crucial value in all of statistics, so you should feel comfortable with its meaning, if not its derivation. And note, importantly, the value of, or the effect of n on the standard error of the mean. This standard error of the mean is a way to capture the error variance in our sample. And clearly, as you increase n, you're increasing the size of the denominator of that fraction, and you're reducing the error in the estimate itself. And finally, central limit theorem. Central limit theorem is important to statistics because it says that when you have sufficiently large samples, the sampling distributions become normal or essentially normal. And they're normal with the same characteristics as the sampling distribution mentioned above. The mean is an unbiased estimate of mu, the population mean, and their standard deviations are s over the square root of n.